Hey, what's good? It's not how you start it. I'll just go over brief our drive. So 2, are the pump and motor running? 3, are there any hydraulic fluid leaks? 4, is there fluid in the fluid reservoir? 5, is the filter clogged? 6, is there air in the hydraulic system? 7, are you using the right fluid? 8, is the pump or motor making strange noises, or is it louder than normal? 9, are the hydraulic hoses in good condition? And 10, is the relief valve properly adjusted? So these are the things you need to check and ensure that your hydraulic system is working great if you believe it is a hydraulic issue. All right. Again, you can find this article in our drive. It should be available in our description. Let's go ahead and move on to the ASE questions. All right, so this is the ASE questions. So this is just looking at just 10 problems. So instead of trying to overload ourselves and try to get all of it at once, this is going to be focused on just really how to drag this for the most part, and we're going to use it. So we're going to have it read it out.
While discussing the brake hose removal and installing that cannot be rotated.
So we're going to go with both. The dreaded commercial. Right, let's go.
While discussing the fact, Technician B says the angle low pressure fittings. Technician B says requires special tools and processes for flaring. Technician B says that ISO and SAE flares are interchangeable.
Hey.
Who is correct? Technician A says an ISO flare or bubble flare has the body of the part.
Let's say A. Oh, lamp systems. Technician A is an open in a packet. Then the code for a short. I think I keep getting that one wrong.
Schematic diagrams can make troubleshooting electrical problems easier. Technician B says if several circuits fail at the same time, check for a common
schematic diagram for troubleshooters. I was gonna help you. And then says if several circuits fail at the same time, check. Yeah, both are right.
As the higher the number in AWG, the smaller the. Who is correct?
This is either A or B. We're gonna go with A. The higher the number of AWG, the smaller the conductor. Can be activated by different switches such as the reservoir. Technician B says that the brake system warning lamp should light briefly when the ignition is turned on. Both are right. Last one.
Technician A says late model vehicles are equipped with computer control brake and stop lamp circuits. Technician B says on some vehicles the turn signal and brake lamp switches are inputs to a module that delivers power to the respective bulbs. Who is correct?
I'll say both. Alright, so what we got going on, if you want to check out Quizlets is a great resource if you're preparing to test for anything. So let's go ahead and continue on, and we are now going to be watching a few videos that's going to be essentially, one is going to tell us how the hydraulic brake system works, and the other one's going to be more of a troubleshooting episode from the guy's like 22 minutes. Album 79, that's going to be the one that's going to be like 20 something minutes.
Hey guys, welcome back to the channel. It's quite easy to understand how a brake can press against the wheels for stopping them. It's very evident that the bicycle brake is completely mechanical in operation. But do you think that we have the same setup for motorcycles and cars? If not, then how do the brakes in them operate? System, which is our topic for today. As the name suggests, the hydraulic braking system achieves braking with the help of hydraulic fluid. Hydraulic fluid is preferred because it is considered to be incompressible. When you apply force on the fluid, it will not compress, but it tends to transfer the force in accordance to Pascal's law, which makes it an ideal medium in the braking system. The hydraulic braking system was patented in the year 1970. It was first used in passenger cars in 1921. Based on the type of frictional contact area, hydraulic brakes are of two types: drum hydraulic brakes and disc hydraulic brakes. First, let's start with the drum hydraulic brake system. This type of brake is also known as internal expanding brakes. From the name, it is quite clear that the braking occurs when the brake shoes present inside expand against the brake drum. A typical drum hydraulic braking system consists of a brake pedal, a reservoir, a master cylinder, brake lines, wheels, and master cylinder by means of a connecting rod. The reservoir consists of a piston that pushes out the hydraulic fluid. Brake lines carry the fluid from the master cylinder to the wheel cylinder. Wheel cylinders have two pistons and are placed inside the brake drum. It receives hydraulic fluid through brake lines attached to the wheels, and it houses the wheel cylinder, expand and create friction with the drum for stopping the brake pedal. The connecting rod operates the piston in the master cylinder. The piston forces the fluid in the master cylinder through the brake lines to the wheel cylinders. When the fluid reaches the wheel cylinder, it pushes the piston, and the piston in turn makes the brake shoe expand against the brake drum.
I really like this video. And then the fluid is then pushed to the four wheel cylinders through the fluid hydraulic lines.
Hydraulic system, it has a disc brake setup instead of the brake drum. It has a rotating disc that is attached to the wheel hub. There is a clamp-like component called the caliper, which has piston. This is how a hydraulic brake system works. If the master cylinder is divided internally into two for transferring the brake to both front and rear wheels, then the brake system is known as a dual-acting hydraulic brake system. The hydraulic brakes are very much superior to the mechanical brakes in various aspects. They are quick in response. They encounter less wear, as it is not a completely mechanical system. Less effort is required when compared with mechanical brakes. Exposure to high temperature conditions can affect the property of the fluid. Presence of air in brake lines affects braking action as well. Well, that's it for this video, guys. I think you're clear about how hydraulic
Hey guys, welcome back to the shop. My name is Adam, and today my buddy Paul has come by, and he is going to give us a hand and talk about some hydraulics. So we've got a few different things that we're going to discuss with this system here. This is a really nice hydraulic training unit that shows you all of the fundamentals on a hydraulic system. And Paul is going to go over this. So, by the way, I wanted to point out that Paul has been designing hydraulic system maintenance and that kinds of things. So, we've got a number of things over here on another table that you can't see yet. That some other components and parts. And so, I've got some things here. It's going to be 4 sessions. And your first session is going to be components of the hydraulic system and fundamental elements that govern all of hydraulics. Okay. Your second session is going to be component operations, and the 4th session is going to be how to prevent the most hydraulic. We're going to let Paul step in here and go over all of these subjects here, and I hope that this helps. It's myself included. I'm getting something out of this today. And he showed me a few things on this, and it's really interesting. We're gonna let Paul step in and start talking about the system components here. Okay. Hope you guys enjoy.
You get a brand new AC and heating system in Metro Atlanta from just $72 per month with 0% financing for 12.
Hi, this is Paul from the shop. And Adam's invited me by to talk a little bit about hydraulics today. And as you can struggle with out in the field when they're trying to troubleshoot and things like that on a hydraulic system. So what we'll do, I've broken this down into a hydraulic system and some speed and things like that, and how they fail. I got a little, and how to prevent that. And then the third session is going to be about inspection and troubleshooting. That's always a common problem and of interest out in the field. Realize some things that they have to have for troubleshooting. So we'll go over that. And then the fourth session is a little bit on safety, most common hydraulic accidents and how to prevent those. Definitely don't want anybody getting hurt out there doing this, so we'll talk about that. When I do a video or a class or something like that, I want to make absolutely sure that there's an objective that I want people to walk away with. So in this particular session, components of hydraulic systems and fundamental elements that govern all of hydraulics, what I want you guys to walk away with on this is, after completing this session, you should be able to field identify the 10 essential components used in heavy industrial hydraulic systems: reservoir, valve, linear actuator, which is a cylinder, a rotary actuator, which is a motor, and fluid conductors like your tubes, hoses, fittings, things like that. And understand the fundamental elements that guide all of hydraulics. So if you walk away with understanding that pressure is force out there trying to troubleshoot hydraulic problems. Alright, what we're going to do now is talk a little bit about different components in a standard hydraulic system, industrial hydraulic system. So the first one you have is a reservoir, right here. And the second time we get finished with all these sessions. Next is called the prime mover, which is usually an electric motor over here that actually drives the pump to turn. Alright, the next thing is a hydraulic pump. And you'll notice that the pump is mounted below the oil level in the tank right here. And that's always the best way whenever the pump is below the oil level. So that's always the preferred method on the pump. Alright. So then you move up here to the safety relief valve. And what the safety relief valve does, it protects the system from overpressurization. Okay? So, next thing we have is the filters. We got a filter back here. It's a little difficult to see. And then we have inside the tank here, what the strainer does and how they fail. Here's the directional valve here with your hand. Next thing we have is a linear actuator that comes out in a straight line. And the next one is a rotary action. Go in and out or around and around, and that is it. So that's what makes that really simple for me to understand, and should make it simple for you guys to understand as well. Alright, the last, fluid conductors, and that is your hoses and tubing and fittings and things like that. Of course, these components wouldn't do you any good unless they're actually hooked up. And you have oil tank to your pump. Then you come out of your pump with this hose right here into this block here. Then you come with this hose right here into your directional valve. And here's your two work lines right here, your A and your B work line that go out to your hydraulic cylinder. And then here's your tank line that actually goes back through the filter to the tank. So that's the essential components of any hydraulic system in order for it to function, is those components right there. Alright, the definition of hydraulics is a means of transmitting power by pushing on a confined fluid. As you can see by these hoses and the way all this stuff is hooked up right here, that fluid has to be confined to be able to do work. Whether it's pushing this cylinder out right here or rotating this hydraulic motor right here, that fluid is confined in all these hoses right here. So that's how it actually gearboxes and chain and sprockets and things like that. The second one is electrical with variable speed drives and things like that. And then the last one is hydraulics or fluid power, hydraulics or pneumatics, either one. So this is what we're going to talk about today, obviously, is hydraulics. Alright, back in 60, confine a fluid and compress it. It is equal and opposite in all directions. So that is the basis of all. Fill up the back of the cylinder right here with hydraulic fluid, and it's because oil is incompressible, it actually makes that piston move right there. Okay? Is the first one is flow makes it go. Flow is speed. If your component is speeding up or slowing down, that is a result of the flow that's coming out of your pump. Okay? So I'm going to turn this system on right here, and what it's going to show you is this pump is pumping right here 1.8 gallons per minute. Okay? So that pump is pumping 1.8 gallons per minute, and I'm not moving anything, still pumping fluid. Alright, where is that fluid going? Okay? It's going over this relief valve right here and going back into the tank. Okay? Through this filter back here. Alright, so the only way you see fluid right here is when I actually actuate this cylinder and make the cylinder go in and out. Alright? So that's one of the things that that's a common thing that people don't really understand. They say my pump's not pumping enough pressure. So what I want to do is go over that real quick. Alright, the only reason I'm showing that oil right here across this spring inside this relief valve right here. Okay? So you'll see if I move this relief valve in and out, the pressure goes up or down based on the resistance to that oil that I'm pushing across that orifice right there. Alright, so what I'm going to do is prove to you pumps don't pump pressure. Alright, I'm pumping 1.8 gallons per minute right here. So what I'm going to do, so what you'll see is, you see that pressure drop, it's not having to go over this relief valve right here. Okay? So as I drop that, open that up more and more and more, you see the pressure drops down. And now I'm going to open it all the way up. So the only thing you see right here on the gauge is about 10 psi. And the reason you see that 10 psi is because it's taking that amount of back pressure to push that fluid through these fittings and through this block right here and make it go back through this filter into the tank. Alright, so as a resistance. Okay, so I'm going to shut this and make the resistance come back, and you'll see that pressure go back up. Okay? So what I just hydraulics is flow of speed and pressure. So what we're going to do is show you that it slows it down. So that'll be pretty right at about 1.8 gallons a minute. Let's cut that down to about in half.
Find it at BioLife. Up to $800 is waiting for you.
So a little less than 1 gallon a minute, something like that. And then we're going to time this coming back out, and it should be about half. It may vary just a little bit because of the oil is kind of cold. Alright, that was perfect. It's about 7 seconds. The other one's about 4 seconds, so that's perfect. So the point was that when your flow drops, slows down. So when you're troubleshooting a hydraulic system, it's very important to understand the fact that flow is speed, and if you're not moving as fast as you're supposed to, you're losing. Okay, what we're going to do now is, we talked about pressure is force, flow is speed. So what we're going to do is prove that pressure is force by using this chart right here. Go down till you see a 4-inch bore, and then come across to the right until you get under where the pressure says 750 psi. Alright, if you look at that number, that's 9,425 pounds of force that a 4-inch bore cylinder can push at 750 psi. So what I'm going to do is prove pressure is force. So right under 1500, and you see 18,851 pounds of force. So there you see that number doubled. So what that means, alright, what I want to use this, have problems with electric motor, this chart, which is a constant. So what that increases, or your right here, here's a kind of a neat chart to show you that, sort of demonstrate it. You go down the left hand side of the chart until you find 10 gallons a minute, 0.75 horsepower in order to run that system. Alright, if you double the pressure to 3,000 with the same 10 gallons, if you double your pressure at the same gallons a minute with gallons per minute. So if you look at 1500 psi, if you double your gallons per minute, 50 is. Alright, what we want to prove with this is hydraulic horsepower either goes to work or it goes, example of that, there's a hydraulic cylinder over to the right. You see I'm measuring that 90 fitting right there, and it's 3 degrees hotter. So what that shows you is that when oil has to reduces down, pressure drop.
Check this out. I'm going to show you how I afforded this car. Okay, you ready? All right, 108.
With the little test unit for a second before we get ready to do a hydraulic motor right here. So we'll watch this little motor run. Control valve. Yeah, move it. Just using the manual directional valve. That's fine, right? Alright, we can also control the speed with flow control. Yeah, I just wanted to play with that for a second. Job of showing the little cylinders over here working, so I didn't.
Alright, one of the things I really want to you to and flow is speed. Somewhere. So these flow meters right here. Alright. So again, that's a flow meter. So what we're going to do in the next session is talk a little bit about component operation, how these things operate. Everybody thinks reservoir is just a dumb square thing in the next session. And not only that, is what you can expect to see.
All right, so let's get when it comes down to it. Exactly, move on fast, but let's go ahead and then we will move on. Give me 2 seconds, please. So a few comments that was made. Flow made. Then after that, the way fluid works, the control kind of valve, the release valve. Introductory. All we need to know is it this line that's messed up? You know what I mean? Like, out of the lines that's possible, is it this line that's messed up? That's what I'm trying to say. So tomorrow, what we're going to be focused in on is going to be disc brakes. Okay, this was a level of disc brakes. We're going to identify if it is a bad assembly, all inclusive, meaning from all the way from the control arm, as far as the arm, all the way to the hub. You know what I mean? Like, we just gonna, if it's bad, we're gonna just basically identify and say, hey man, it's not good. Might as well get new pistons. It's been honest, unless you want to go identify if it is a bad assembly, all in repairing. And we're gonna look at some literature, videos, and PDFs and JPEGs. So after we're done with that, before we could run the block again and really yeah, that's good enough right now. So I hope you enjoyed learning about the hydraulic system. Right now we are about to go into the wrapping course as far as the training that we got going on. That's going to take place right after this. Well, no, correction. I do have a meeting I have to go to. Right after that meeting, we will be essentially finishing today's wrapping course, and I have good news, for us. And I also made it a point to order the things that need. I just went like, man, let's go ahead and get this product and thing that costs money to move. It's gonna cost a little bit more. It is what it is. But yeah, so with the hydraulic system, we are complete. Tomorrow it's in the same category. So it will, that'll be the last one of concern. And then we have the ABS and then general engine. So that's light work. Once we are done with those 4, because I'm included disc brakes. Once we're done with all 4 of those, we sometime this weekend. Just because it's like, hey, if that's the only thing I'm doing is just taking an assessment, then it is what it is. And that will be the round 2. The third round will be reorganized based on quantitative, qualitative data, and that'll be from whatever the test that we just took tells us. It's going to be like 3 sessions at most, and the main thing is trying to figure out where we're weak, how we can build our strength in as far as being able to know we're going to crush. Because when you are spending a lot of this people, when it comes down to it, man, that money, yeah, it's only $64, but at that time, 16, and then, you just keep, because before you are ASE technical master tech, and that's the goal that I'm trying to get whoever in exhaust. And then it's just the ABA right there. It's going to be 5 days. So we're going to work. That 4th round is going to be 5 days. And what's going to happen is the worst 3, and then we're going to have group sessions. It's going to be 1 day focus on this. Hold on. 1 day focus on this. Next day focus on the second weakest. Then the next day focus on really going through the other ones. So it's a total of 1, 2, 3, 4, 5, 6, 7, 8. 8 different categories. Lowest, we still have 5 more to go. Somehow, some way, we're gonna chop up them 5 different ones, and we're gonna give them 1 session, if so that we can get it back on track. That's okay. The reason why is because we need to elevate our game. In order to elevate our game, we got to go to OT in it. So that's an answers. And what I mean by shot work is, I am looking to turn into the business fleet because we run box trucks. So I would like to take care of minor stuff, and then that's going to have me have to learn how some of that. But that'll be another channel. And then if I have any kind of questions, any comments, any ideas and things of that nature, go ahead, feel free to write it down. We're going to go ahead and cut out, and we're going to be continuing with the wrapping session.
They got declined again? If you don't have money, just leave.